Good morning, weather technology students. My apologies for not being able to be here in person. I am in New Orleans at the American Meteorological Society annual meeting. So what we're going to do here over the this week is we're going to have a couple videos that's going to help you spin up on some of this new material. But then there will also be at least one lab aid in each section, as well as our new staff meteorologist David Goins around to help you all get spun up and get this next homework assignment underway. And so we've already talked about Linux a little bit. You should have completed your homework assignment by this time. But what we're going to get into today is a little refresh of Met 103 material around surface data, but then we're actually going to get into using GEMPAK in a subsequent video. And so this is going to be a relatively short video to start off with here, just rehashing how we take surface data. So why surface data, we might ask, and if you want, you can follow along at home in your packet, Introduction to Surface Observations. And so obviously we live at the surface, so that's where we have collected data for a long time, a very long time actually. It wasn't always the most accurate measurements back in the day before the invention of the thermometer. But even in the earliest days of the United States or the colonial times in American history, we had regular surface weather observations. But it took many, many, many years before we actually decided, oh hey, we can put this data on a map. And so then the question was, well, how do we get this data, all this data that we want to collect at the surface, efficiently onto a map and plot it so that it's easily accessible to meteorologists to read and interpret and do that? And so what we need is to come up with this idea of the station model. And so this should be very familiar with you. So here is, an example of a station model. Nothing too new here for you. And so we'll begin in the upper left-hand corner with the TT. The TT is where we put our temperature, right? And so at the surface, what are the units that we use for temperature? Is it Celsius, or is it Fahrenheit, or is it Kelvin? And so in the United States, what we use is Fahrenheit at the surface. Yes, it's not the metric unit. Yes, that presents problems, but that is our common nomenclature. So we use temperature in degrees Fahrenheit. And then you see where there's T sub D, T sub D, that is where we put our dew point temperature, also in Fahrenheit. Of course, then we have our big stem coming off the center of our circle for our wind speed, FF, which is indicated by our flags, and the direction, which is indicated by the direction of the stem. And so remember that in meteorology, we always describe where the wind is coming from. And so in this case, the wind is coming from the northwest. A full bar is worth 10 knots. A half bar is worth 5 knots, so our wind here would be 15 knots. And typically use knots unless otherwise specified. Some other ones would be miles per hour, which a knot is close to a mile per hour, but not exact. Or meters per second, which would be the metric unit. But when in doubt, assume knots. And then if we had a full flag on here, a full triangle flag, that would be worth 50 knots. So if we look out over to the left-hand side, all the way out to the edge with the VV, VV is where we put our visibility measurement. So obviously at the surface, if you've driven around at all during the wintertime or during fall when there's a lot of fog, we need a way to express how far we can see out in space. And so visibility can be a maximum of 10 statute miles. And so here our units are miles. Typically it's not reported if it is 10, but if it's anything less than 10. And so you may even see a fraction here. You may see 1/2 for a half mile visibility. All right, let's jump over to the right-hand side. We have our PPP, which is our pressure, which is in a 3-digit code. Okay, so we have to remember back to Meteorology 103 here. And remember that if our first number in that area is a 0, 1, 2, 3, or 4, we're going to add a 10 to the front. And if it's a 5, 6, 7, 8, or 9, we're going to add a 9 to the front. so that we can get a pressure, a mean sea level pressure that is close to 1,000 millibars, because 1013.25 millibars is average sea level pressure. And so that means the third digit on here of the PPP, so that last one, the one that's furthest most to the right, we add a decimal point before that. That's our tenths of millibar area. And then the lowercase pp below it is our pressure change. And so this is pressure change over the past 3 hours. Sometimes you may see a slash that would indicate rising pressure or sinking pressure, but otherwise a positive number would be pressure is increasing over the past 3 hours, or a negative number would be pressure decreasing. And this is again going to be in tenths of millibars, so that means we put a dot right in between the two p's. So if that were to say be 25, that would be plus 2.5 millibars in the past 3 hours that our pressure was rising. Now leaping back over to the left-hand side there, you got that WW. That is the current weather symbol. And so it can be any weather symbol that we have. So if it's, say, a thunderstorm, or rain, or snow, or freezing rain, or sleet, you can have a whole bunch of different things there. Fog, and that's just going to be a symbol. And so you're going to have to look up what different symbols are when you see them on surface weather maps. And through time, you're going to be able to identify them quite easily. And so last but not least, we've left our center circle, which has great importance for telling us how much cloud cover there is. And so the way we do cloud cover, we do it in octas or eighths of the circle being covered. And so if there is nothing in there, if it is wide open, clear, no filling whatsoever, then we would say that the atmosphere or that the cloud cover is clear. And then up to being completely filled, that would be 8 octas, which would be a completely overcast sky. And so you can see on page 2 of your handout, we go through the different octas. In that 4 octas, 4 out of 8 would be half, would be the sky is half covered with clouds. And so here might be an example of an interpreted surface station plot. So we have here 57 degrees Fahrenheit, that's correct, at the surface. And then dew points is also in Fahrenheit, as indicated here on our plot. And so that's a pretty high dew point. Relative humidity would be pretty high in this case. Here we have a weather symbol with 3 dots. Anybody remember what 3 dots would be? Sure enough, that is rain, and that's actually moderate rain. So it'd be raining pretty good at this location. Sky cover is interesting here. That is not filled even with our rain, so you can tell this is just a made-up event. So that would be 0 octas or clear. Here we have a wind again from the northwest at 15 knots. Our sea level pressure, we have 107. So do you want to add a 9 or a 10 to the beginning of that? If we added a 9, it would be 910.7 millibars. Is that close to 1,000? Or if we added a 10, 1010.7 millibars. That one is closer to 1,000 millibars. So in fact, our mean sea level pressure is 1010.7 millibars. And then our pressure trend here is -6. So that's minus 0.6 millibars in the past 3 hours. And our little symbology there would be that it was falling and then steady, which makes sense for a small pressure change over a 3-hour period. And so here's some examples of some mean sea level or some surface plots here across the country. So this is from the RAP site. And so you can see that we had this time, January 6, 2012, a cold front moving through the Central Plains and up into the Great Lakes. But we were still warm here in Valpo at 54 degrees Fahrenheit. Quite nice. But then behind the front, it was getting chillier, but not too terribly cold. Here's another example from the kind of now sort of defunct Hoot site from the University of Oklahoma. This is from January of 2013. This map was actually made using GEMPAP, which is what we're going to be starting here in just a little bit. And so you can see the wind speed and direction all over the place. Here they did not follow the common nomenclature for pressure, and so you're given the full 4-digit pressure, or 3-digit if it's a 900 less than 1,000 millibar pressure. And then they color-coded temperatures in red, dew point in green. Very common thing to do, and you see some small weather symbols there, especially down in the lower right-hand corner of the map where there's some fog and rain going on over Virginia and North Carolina and West Virginia and Kentucky. And so that ends this video. And so now what we're going to do is we're going to go ahead and do some GEMPAK maps. We're going to create your first GEMPAK map. So go ahead, and if you've not yet logged into the computers, go ahead and log on and go ahead and open up that terminal window. And we'll go to the next video to do that. And don't forget, at the end of this week, we're going to have our first weekly quiz, and so look for more information to be coming on Blackboard for that. And we'll give you another reminder on Wednesday or Thursday, depending on when your class time is.